so that at least if we find a solution during the week, we have not wasted time doing the project. Yes. So the challenge is, I don't know if I said this before, in hello, which together the people online. You can hear me. Okay. Now, the thing is, since we have the challenge of GIS role, and it needs more accounts if we don't have for us or for our laptops to be connected. So for that reason, we couldn't find any quick answer for it. And we are switching or compromising part of the plan was to learn Python, which is open source. So we are switching to Python to start working with it and we keep finding the solution. So this afternoon for us to be productive and make sure that we use our time well, the whole course. We're going to switch to the Python. I'm training is going to guide us on how to make quick installments, quick installations, and to move by it. So I hope everyone is in track. The same thing for people online. For us to follow the training. I don't think everything is in the Google Classroom. So take the Google Classroom as their instructions on how to install the needed software for the languages and library.
So anyone needs some help with Python? Just a minute. So now you're going to be a programmer. So I have prepared it will be even very simple to use. It's a very simple guide on how to use Python, but when you have knowledge of use, all you have knowledge about using the GIS data. So before we start the exercise, different types of GIS data. We see that the performance of GIS, the capital data, the analysis data, collecting data and presenting them. When you talk about GIS data, it's already on the Google Drives, and then on the Google Classroom. So you will see which kind of functions. We have the tutorial, is a one tutorial. And you can also so when you open it, you will see GIS data when you get back to the first. I want you to open this file. Then after opening it, we will now get the on how to start using this. There's no installation, it's just everything we read from the web. We just need internet. Okay. So to download this, we are going to go to the Google Classroom and then check the exercise 1 tutorial. And then again, day 1 exercise data. So you click on it, and then download the data. I mean the PDF, or you can just open it online if it's possible. And then go back again and then download the datasets. Let's first finish this one and then we go together on how to do that.
Sorry, what are we doing now? Because I can't really hear what you said. The voice wasn't clear very well, so it's really hard to listen to what you're saying. And if you could just recap what you said, and then we can follow up.
Okay. Uh, Let me tell the trainer to make a recap for you because you have been come late, a little bit late. Yes. Hello.
Yeah, I wasn't late. I was here, but I can't hear. Like maybe the speaker is not near the speaker, so that's why it's really hard to listen and hear what he said.
Okay, we were saying that because GIS is somehow have updated for the protecting the its privacy, we are going to shift to using of Python, and then after discussing with this problem, we will come back on it later on instead of wasting all the time and all the day doing nothing. We are going to shift to Python, and then we will come back on ArcGIS Pro afterwards. So now you are getting the sense of what we are doing.
Yeah, okay, thank you. So is there anything that we are doing in the meantime?
Yeah, check the Google Classroom. There are 2 uploaded documents. So the two recent one, we are downloading it. One is like a PDF which is highlighting what we're going to do with Python. Another one is a zipped dataset. Maybe we are going to use the data too.
Okay.
So we are in a task of downloading it. Therefore, after downloading it, he is going to resume with what we are going to do with it.
Okay.
Okay. Thank you.
Thank you.
When you get to the content, for instance, on this one, on the exercise, you will click and then click open the monitor. You will click. So this is the you don't need to download it. It's not a small access to it. And then on the zip file, it opens this tab. You can either use this download and then we'll use this one. You have to download it from the website, and here you just download anyway. It's just a little. I'm sure you did that you have your data in the laptop. So the zip file needs to be downloaded on your device. So when you are set with downloading the data, you have to unzip it. So on your local machine, you do right click and then do unzip or extract. Extract all. Is to extract the information or the files in the folder. So when you click on extract, or if you have an extension of extracting, you will see another pop-up, but we can use extract all. They ask you where you want to paste it, and then do extract. So you will have two folders, one which is zip and another one which is us. You can see. The Google Meet. Oh. So after downloading here, the data, you go to your downloads of where you have the data has been downloaded to, and then you right click and then choose extract. Extract all, and then you will have another folder which is called zipped data. So in here, this is where we have the data we are going to use. Yes. So everyone should have this folder on his laptop, so that we have access to the data that are going to be used. So we have the zipped file and then the tutorial, which is going to guide us.
Jen, this thing is a bit complicated. I couldn't download it.
Because we are going to use a Google platform. We're going to type in any fire. You're going to type in Google Colab. Google Colab in the browser.
Where?
Yeah, we are typing Google Colab in your browser, maybe a Chrome or another one.
And then we choose this one, Colab.google. So what is it? It's a hosted Jupyter Notebook service that requires no setup to use and provides free access to computing resources, including GPUs and TP views. So normally, as you know, even just using what we are just doing, the ArcGIS desktop applications. So this one, there's no need of installing anything because it's an online platform. So it doesn't require any setup and it provides free access to the resources. So how to add the data on the map and visualizing them in our first exercise. So the Google Colab, you just click on it. You just need the Google account. So we are going to use the accounts we are using in the Google class. So there is two ways to start with. We can we'll start with a new notebook because this is the first. It's like creating a map or starting the project when you are using ArcGIS. So we are going to click on the new notebook. It will be like a project, what you are going to be doing. So while it is opening, this is the where it opens. So this is the place that we are going to be using for writing codes and testing information. And then when you have an issue with the codes, you can ask the chat box, which is Gemini, to help you fix the error. So this is an advanced platform. If you have even no knowledge about what you are going to do, you can just ask any question. Like I'm testing something here, but I don't understand what it means. You can still ask that box to help you understand what you are doing. So this is the first environment that we are going to be using. You are going to perform the same analysis you do when you are using the desktop application. Very similar. There's no difference. And even the tutorial I've prepared, they are expecting you to be knowledgeable at least about using ArcGIS. So let's start. If you have this site, you can start. Anyone left?
Are we logging in with our Gmail account or your Google account?
You need to sign in. You need to sign in because they will ask you your Google account.
In our Google account.
It's not Google account.
Hello.
There is another way of connecting. I think it will not stop us to work on it. I will check maybe there is need of accessing your Gemini account, but we can start. Mm. So does everyone has this interface?
Hello, sorry, do we need to log in to the Google Colab or we don't need to log in at all?
And, so the first step when you are using the Python is what we call importing libraries. So what does it mean? So for instance, when you're using ArcGIS, when you open either ArcGIS or QGIS, uh, what we call the processing. So, but in ArcGIS, they are loaded automatically. So you don't need to do anything. But in Python, we need to start, because we start with an empty box, you have to manually tell Python what I'm going to do. That's the idea. So to tell it what you want to do, you have to instruct it. Like what do you want to use? So anything you're going to do, you have to first import like a tool. So before we paste this information in there, let's see what does it mean. So importing, it means like importing an extension. It's like calling a toolbox. An example here, which is import your banners. That's what is written there. So you want to get, if you want to get something that enables to do any kind of analysis related to geospatial. So when you're using Python, you normally use this library called Geospatial. It's the one that has everything we need as tools to do the analysis. So sometimes you will see they say import Giovanna as GPD. GPD is like a nickname. So because the library is too long, you can give it like a nickname. So for instance, that one was named GPD. So that's how you, when you're going to use it again, you're going to read that. When you type in GPD, you mean I want to use something for your banda. And then another library, they say it is called large.lib. This is like when you want to create a layout, something to come as a map. You need to use this type of library. So when we say import this library, it means you want to have a layout view. So this is the way you start with. You start by calling or importing tools using the import geopandas, and then when you need to have a look like a map, have like visualize your data, you need to have such library. So we are going to use the two. The third one, which is called Rust Rio. This is the one you see here. It will be used when we have images, or what we call raster data. So those are the main three lines you have to write and understand what it means. So normally people type in this information and then they know what exactly they are going to do. So for this, you understand what it means. So we are going to copy only the three lines and then paste it in the collab. You can even just type it, but it's simple. You can just copy. And then paste it in the first space above. After copying it, and then you just need to on the this one. There is a tutorial PDF. Yes. It's on the Google Class. You just need to copy this one and then paste it. So after pasting, what you do is just to run. When you run, it's ready done. So later maybe we could explain this one. So for instance, you are importing things you don't understand. You can ask this if you have already connected. I think I will just need to check how to connect the Google Colab with the Gemini. I think it's a check. You have to first allow it to access your Google content. It's called Gemini. Let's see if you can do it. Just type in here above Gemini. Gemini. Because for me, I'm already using it. Maybe we need another laptop to see. We'll go. Try to sign in and see if you can have it. But let's continue. I think I will just need to check how to do it and then show you later. So this is the first step of importing the data. So if you want to go back and read more in detail, you can use this one and understand. So the second step is to load the data. So when you're using AppSeries, you normally use the add data button and navigate to the folder from your computer and then have them add the GPO to your map. So for instance, let me give you maybe my laptop is. I will show you how it works when you are using the actors. But here you have three main information to consider or add in the data to the notebook. First, we have to think of a layer, the data set. So a layer name or a data set, we call it a variable. Similar. When you see a variable, it means your layer name. Second, the function of adding the data. When you click on adding data, normally in JS, it means in Python a function. It's something you want to perform. And then when you are finding the data on your machine, here we use what we call the file file. The file file is something showing where your data is stored. So we need the two information so that we can add the data to the map. So let's try it and we'll see how it will be very quick. So to find the variable is on the left, and then the function is on the right. Here in the script. So for instance, we have the data. I have shared the data of district. I have also shared the data of roads. So this is the variable, which is the name of your data sets. And then when you want to add those data to the map, you use the GPT, which means the GeoPanda, to remember. And then I want to read. I want to like extract those data from where they are stored. And then here they ask you, where did you store your data? This is the file, just the file part. So this is what we are going to do. And then we are going to use, again, the name of the layer plus another, what we call a function, so that we can see this data we are talking about. So we first see the data about the district. Because these data are on the zip file, which I told you to download, we are going to first add the data to our Google Colab. So let's first copy this information from districts to here. Just copy, go to the Google Colab and then just paste. When we first start, but let's first open to this course. Just copy and paste. There is when you just hover below this in the middle, you see code and text. Code and text. So click on the code. If you want to add a description, you first maybe add like loading the data. This is where you just type. And then for the code, you just add the code space and then type in the information.
Sorry, I'm having a data source error, which means that I saved my download in another file. So maybe how do I correct that?
Let's continue. So
Yeah, hello, can you hear me?
it's from this one.
Hello? Hello?
These are the three.
Hello?
Okay. So
Hello.
when you run, as you have started running, what do you see?
Hello. Hi.
Just click on the run.
Yes, yes.
Can you hear me? I'm having this error.
Yes.
Oh, which
This is
one?
the typical way of having an error.
Can you show me in my WhatsApp?
So
Yeah,
WhatsApp,
it's the same.
WhatsApp
It's the
group.
same.
just click
Don't worry. It's the same here.
on someone
Okay.
and that's line and read what they are saying. They are saying that your path it's not in the direction. No such file or directory. So where do we find the directory now? To understand, because we've said that we have the layer of the districts and the layer of roads. And then when we like imported them from the directory, we say it's not, it's like it's not there. There's nothing. So the directory of Google Colab is found on this site. You see a folder here. You click on it. So there is no data you have already uploaded. So we have to first upload the folder containing all the data that was in that zip file. So it's just simple. Click here on upload. On it, I have clicked on the folder here, and then click on the upload. So when they ask you where are you going to find your data, and then it will just show you how to import your data from. So go on where you have extracted the data, and then enter inside the zipped data, and then click Control All so that you can bring everything together. So I will repeat it again, and then you click here on Open. When you click on Open, the data starts to be shown here. And there is just a warning saying that when you are in this file and you write, when you close the session, you might lose them. And it's okay because we have them on our laptop. So everything you have uploaded is here. These are the data that we are going to use. So again, I will repeat it again. So the folder of where we keep the data that is going to be used in the notebook are stored here. You just click on upload, and then you go on your local machine where you have stored them. You can even just click one and just upload it, but because they are all in one folder, you just need to copy all everything. And then when you click open, it's like upload. And then when you upload, it will appear here in the directory. So check that you have the districts, we have health facilities, we have population, and what else? We have roads, and then we have also another village. This is a TIF file. This is how images are stored, storing the visual information. So the rest of the data sets are what we call shapefiles. The shapefiles normally have how many files? 1, 2, 3, 4, 5, 6, 7, and 8. It has 8 files, which makes it one dataset file. So when you don't have all this information, you might not view your data. So check that you have all all those data sets. Check that you have all the data sets. Yes. Don't forget this is the one which is saved in time because it's an image.
Hey, Iradukunda. Iradukunda. Hi. Mr. Iradukunda. Hello, Iradukunda.
Yes, I can hear you, sir.
Okay,
Yes.
which issue do you have?
Which data set are we importing? Like, is it because they were saying exercise 1 and
No, we are you see on Google Classroom, there are
yes,
2 recent uploaded files by our trainer.
yes,
And there is one which is about exercise 1 tutorial.
okay,
This one is the PDF which is highlighting what we are doing. So you see we are copy some code and then we paste them somewhere.
yes,
And there is another file called day 1 exercise data 2.
okay,
The second one.
yes,
We downloaded it and then it comes as zipped file.
yes, yes. I already did that. Like, should I import the 1 exercise data 2 or
That one. After extracting it, it will be having so many files, and then that's one which we are uploading to Google Colab.
oh, okay, okay. Let me do it.
Okay.
2 steps. So here, you're going to change this part of where the districts are stored. So you come here again, and then you check for districts, and then you only choose the district which has dot sh, which is the shell. That's only what we put. You just click on the points there, and then you just copy the path. You copy the path, and then you place it where?
Can you zoom out, please?
Between the double points. In the double. Yes. You first remove this one, and then press the new path. It will show you where to go. In the contents, the district. That's one. And then it's this one again. It is similar to the roads. You can go back here and then check for roads, and then check where roads have the SH. And then you copy the file. Paste it here. Remove and then paste. If you have already this, you just need now to click on the run, and it will tell you the first information you have, which is the districts. So you can again just, instead of the plot means mapping, instead of using the districts, you can use the roads. It's the same. You can just copy the roads, replace it with the district, and then run again. And then you will see the data set of roads you have. Here, before the word plots, plots, plots.
Sorry, can you zoom out? Can you zoom out? Like it's too enlarged, we can't see it.
These are just, they are still seeing. It's just viewing one by one.
Mr.
You can
Benjamin,
even just add a place here.
okay.
Can add your own code below and just put the name of the variable, which is the district. Then you again put dot plots, like this one. The roads, dot plots. You can again put the districts dot plots, which means just viewing the data. Again, do below here. Add a code. Yeah. Add a code. This one. Add code and then just type in roads dot plot. And then you put the open brackets. Report. It's below. Below is 7. I want to see the other data, the health facilities and the population data. How can we add them here? We have added the roads and the districts. So we are going now to add the health facilities. The roads, the districts, and the health facilities. So to have the health facilities added up, I'm going to just remind you. You add the code, and then first you have to give it a name. So these are health facilities. So for me, they are even giving me the suggestion. So first, there is a function for reading the data from the directory, and then report. That's only what we need to do. The standard Excel file, and then it goes to the file path from here, which is yourself, and then you put it on the map. And then you click on run, and then we will see the health facilities. The lines of the form.
Hello. Hello. Hello.
this is something that reduces the physics of the guy. Yusuf, can you hear me?
Yes, I can hear you. I'm still like after copying the part, I'm still getting the error, like saying that the error is still there. So I don't know what is going on. Can you track back from that?
Sorry, I can't hear you.
I said after copying the
Please
part,
just check the.
can you hear me? Hi, can you hear me?
Yes, I can hear you. Start speaking. Continue.
I'm still getting the error message. I don't know what's going
Okay.
on.
You can just send me the error.
Okay. It's data source error again.
Just copy. You can even just copy the last line.
Here.
So I think the error you have copied the wrong part. Should be words or words is not SHX.
Yeah, but after loading, after running the code that you sent me, that is what I got.
Oh, can you share your screen?
Yeah.
Yes. Scroll down in the error. Again. Go back about. Go back about.
Can I start again?
Yes, that's okay.
Is there any problem? Because I was not around.
Yes,
Hey,
want to.
okay.
Yes,
Let
So
is you
I'm
is
copying
present.
this.
you can yes, you can copy that one.
And from here
Yes,
Yeah.
to here, and
yes,
then the road
yes.
from here, and then the change this part to road.
Yes,
You can
it's not
even leave.
here.
Okay, okay. Yes. Delete one. Yes, yes. Okay.
And
Then
then
run. Mm. Mm. Okay. So is the data set you uploaded the zipped one? Have you extracted it?
yeah, these are the file. You can see them here.
Okay. Are extracted. So after downloading the zipped one, you extracted it.
Yeah.
I think it would be better just copy
Um,
again all the files, then upload this.
These are the
I
files.
think it's
Can you see?
missing that one.
So I should copy all the files again and then open again, upload.
Yes. After uploading this one,
Okay. So the thing is, when I downloaded the zip file, I got like X mark on the status, like it is not checked. It's like there's an error in downloading. but it's still downloaded. Let me download again.
Let's be continuing. Maybe
You can continue. I will just catch up later.
This first give a very short introduction about the data we are visualizing there. So, as we say, spatial data means the location and the attributes. The location is just the data on the map, but the attributes are the kinds of information we have on that location. So, for instance, this is the driving license of this lady. So it shows the location of where it is located, but it has additional attributes like the date of birth, the size, the sex, the height, the weight. These are the kinds of information we have added in this location where this person will be able to have driving license. So we will see what kind of spatial data we have. We also have what we call disputes. Features. These are we will see two types of spatial data. The first one is discrete features. So when we represent this type of data, they have what we call well-defined boundaries. It's like drawing a building. It has defined boundaries. Some examples, maybe a border, like a building, like a road, is something which has a specific boundary. Another type of social data, we have what we call continuous phenomena or data. So they represent the world phenomena. So these are things happening on the surface, but they do not have well-defined boundaries. You cannot have a specific boundary of such data. So an example is like an elevation or temperature. You cannot say the temperature here is 20 degrees. Sometimes it varies depending on the area or the range. And these are the two basic types of spatial data. So let's start from the discrete one. We have three types. We have what we call point. We have a line and a polygon. So these are the three types of spatial data or vector data or discrete data. So vector, we have a point which has a symbol. It's the symbol X and Y. A line which has multiple X and Y's plus they are connected. And then a polygon, again, it has multiple X and Y's, but they are connected fully. There's no space in between. So this is what we call a polygon, a line, and these are the three types. So about those three types, they all have what we call attributes, information. So on each of the recorded information here, like a point, if it's a 1 point, we can have a shape in the table. So the point might have just the shape of the point. We do it as a point. If it's a polygon, we write it the polygon. If it is a line, we will just write a line or the polygon. Sometimes that's what we see. Again, you have the description depending on the information you want to add of the location or social location, you can add them. And then we have the two information here. Because this is the polygon has an area, and the center which is like the perimeter of that shell. So the area is the total area, then the center is the perimeter of that polygon. So a line also has shape layer, that's the shape area. The point is a little drawing. That's how the shape line can be area. So normally this is a kind of a map that you could see maybe online or somewhere else. So the location and the attributes. Let me search for an example of raster data. These are the kind of raster data. It's going to be the money before it's not like image, but not only satellites only images, we also store such information as images. But we are stored as grid for one subvalue. So on each of this area, it might have a value, but because as we said, they are not discrete, they are continuous, they will change. So sometimes might be in red, meaning maybe about higher temperature, and some other areas if you look at have low temperature. Before we go to the part of coordinate system, let's first finish adding the data in the map and then also see how to use the attribute information. So the first step we've done is to add the data to the map. I hope everyone has at least the three data sets. So, and whenever you have any additional type of data, you just need to find a way of adding it here as a shapefile, because total data are normally in shapefile format. And then if you have an image, we will see how you can add such image from here. You have an example of an image, you add it. So let's go back to the tutorial. We have stopped where we were just reading the file or plotting the data to the map. So two main functions we have used, you can notice, you can write it somewhere else. The plot helps us to just mark the data on the map. And then the read file is the one that helps us to read the data from the story. So these are the two main functions we have used so far. If I give you like a file and I tell you just, can you read it, or can you just know if there is already data? You can read it and then just So before we go on step 3, then we have step down here of reading the table. Yes. Scroll on page 5. We're going to read the article. The data other than the location. So in ArcGIS, we usually use the layer in the table of contents and then choose open the active table. So the result of it, it shows you the number of rows in the columns you have, and it shows you the information you have. You have things first and then how to use it. So the head command is the function which is the head. For instance, we have we can just want to learn about I have an example here. Here, when we're talking about the rows, these are the rows. 1, 2, 3, 4, 5. And its associated columns. So here, when we use the function someone who is unmuted. We normally know that the table has columns and rows. So when we want to just know the names of columns we have, in that case we call them templates. Python recorded columns. So you use this function to just load the lambda and the list of columns are. So this is very useful when you need to know the exact spelling. So someone might write the title of their district like this way or this way. So when you use this function of columns, you just read the whole table and see what kind of columns you have. And the last one is the dot shape. This is not a function. It tells you the dimension. If it says 30 to 5, it means you have 5 districts as rows and 5 attributes, columns. So that's what it means. The check. So you know the table how that it is. So for instance, this one, it tells you that you have 30 rows, means 30 districts and 5 columns. So the 3 are the ones that helps us to read the table. Because we have seen that now the data which are spatial, but when you want to read them as tables, we are going to use the three of them. So here there is a function now for the script to use. So the first one is to first do the part loading. The action table. So what we are going to do is to change what you have in the first 5 rows. This is the function. Remember, this is the name of the variable we have created. One importing the district data. Again, in the second step, when we want to just see the list of columns you have for this field, which is district, it will also print us that list. The print means to show us. You know, it's like show me the columns, show me the past 5 months. And then the last one, to check the size of the data. So the output format comes as this way, the number of rows, and then comma, the number of columns. So this is the way of showing it. So we are going to copy this information and see for the districts what we have. Let's copy. We go back to the collab. We add the code and then paste. If you want, you can do one by one. You can start with just the head, which is the rows, and then just click on run. Oh, remember to remove this word you have added of Python at the top. Go down on the fifth page, page 5, page 5. So remember to copy from here, or you can just copy the first 2 lines, 3 lines, the second and the third one, and first read the information. The table shows the first 4 or the first 5 because it starts from 0. If the data are from this for instance, and then the other information attached on the demo section, then the field area, and what we call the topics. These are the kinds of information we will see from the data. So if you have pasted everything, I think you have read also the columns. Becomes me the number, the columns you have in the data. You have the project, your statistics, and this is ID, the chapter, and the check area, the geometry, and this additional policy. And then again, it shows the size, which is the number of rows, which means the number of districts, and then the number of columns. Yes, we try to open also the raster data. The difference between the data and the raster data is that sometimes the raster don't have yes, yes.
That's what we president.
This one?
Yeah. Actually, we have some we have project on that. What is the value that you got in that side?
Yes.
You have project before.
Mm.
So normally have politics. We divide into types of these points. Asking you to go extract them from the file of project. So in the next, then I want to here. Now that transition from to using data and then the flow. So that project here. Then I want more of this and then to put it from there to
Yes. The only process that you need to do is to first have the file, the script file. That's what you need first. Because you need to first have this file. When you capture the data, you store it in a shape file. So maybe the GPS, it can give you just a value, but when you have some value, you turn it into a shape file. There is something you need. So you have maybe to first have it in a table, maybe an Excel, because it is a simple way to record the data. And then when you have it as an Excel file, you upload it here as an Excel, and then try to find a way of reading now an Excel file instead of reading a Excel file. So it's all the same. The only question they ask you is why did you store the longitude and the latitude? Because are the ones representing the location. So when you tell, like when you ask, for instance, on Google on how to create how to read an Excel file which has X and Y using Python. You could get a tool, or maybe let's ask it how to read an Excel file which has X and Y as columns and map it on map it. You have to first upload your Excel file here, and then you use similar way as a script. Just it's there, and then you just change. I think this is the collab results. They are saying, assuming your Excel file is named as this one in the directory, like the folder here aside, and they contain X and Y as columns in your data set, you have to first upload it to the collab first, and then have the path. You see, this is the part of the Excel, and then read the Excel file into what they call a Panda data frame. It's like creating a table from the Excel file. And then here they are just reading the first rows using the head function. This is a way of just, if you have no data, what they might show you. And then from here, this is the second function, creating a geometry column. So creating a geometry column from the X and Y. So creating a geometry from X and Y coordinates, assuming that the X and Y are columns in the table, the latitude and longitude, you adjust the columns if they are different, and then you create what they call a point. So, and the X and Y becomes a point. So after that, you take this, the process of trying to make it the point is to do what we call this the projected coordinate system or a coordinate system, because a point, the one I told you in the morning, the point doesn't just show up anywhere without having a system under it. So these are you have a what we call a general system, which is called the WGS74. It has this value. So after you assign this to coordinate system, and you say your X and Y column, which creates what we call the data frame, which is similar to the shapefile, and then it reads the file. So you either start from the X and Y or you start from the shapefile. Other way of finding data, sometimes I know it's very hard to find some data related to spatial data. There's this
can convert the normal data. Like you may have an Excel with the longitude. So how you can transform this data?
So step is another conversion. So if you have an Excel file, so Excel file normally has the extension. So the first step is to put your Excel file here on the collab directory, what you have already done, just to upload it. Yes. This is what they are assuming. They are assuming, this is an example, they're assuming your Excel file is named, it has a name of points, and it's already in the content. You have already uploaded it. And they assume that you have the X and Y columns. So you have to have the two, because you cannot create the point without the X and Y information. So this is the file path. They have assumed that it's already there. So if you have already this Excel file in the directory, the first thing they have tried to do here is to first read the table or the Excel on its own without first converting it. So first to read the
So when you say that you have X and Y, it's the same one.
Yes, it's the same. Exactly. You just need to specify where does longitude and latitude, the columns. And then, so here they are just reading. If you see, they are reading an Excel file, and here they are displaying, they are just reading you another thing. But if you have no data in this Excel, this is the kind of error they can provide for you. And then this is an error. Why also reading the file? So this is a way of prompting this Python to respond to you when there is an error. This is part of the last part. But the two parts, this is just to read, this is just to display. The first is you have your Excel file now read. Now you're going to transform it into either a shapefile or what they call a geodata frame. So the prompt I have given this Gemini. It was just to transform my XY from the table to points on the map. I've not specified to turn those points into shape, but you can also do that. It's just a prompt of how to convert your points in Excel to shapefile. So from here, they are also assuming you are going to create a geometry column. So every spatial data has what we call a geometry. The geometry means it's a combination of the X and Y. So create a geometry column from X and Y. So it means you have a single value on one side, and you have another single value from another side of the column. But the two, when they are combined, that's when they create a point. One single column cannot create a point. So you have to create a geometry column where they are going to combine the longitude and latitude information. So they are assuming again that the X and Y means it's the longitude and latitude values. Sometimes you have X and Y as title of columns, but it doesn't mean the longitude. So you have to be sure that your table where you have written X and Y, it means longitude and latitude. If you have your column name as longitude and latitude, you just use it here. You just like here longitude and latitude. So this is a function of transforming your X and Y into a geometry. This is where it is happening. So it's happening coming from the data frame. This is the data frame of the Excel file. So the Excel file, this column, the Excel file again from this column, and then it creates the format of X and Y. This is a combination. So this is the new column created from the Excel. So if you have a column, now you want to create like a shapefile or a geodata file. So up here they are just explaining that it's crucial to define what we call the coordinate system. If I give you just a point that has these values, and I didn't tell you which coordinate system to use, the geographic coordinate system, and then you want to put those data on a map, it will just go somewhere else. It might not go on this exact point of information. So you have to give it a reference, something to base on. So a reference, these are what we call a coordinate reference. It means the data I have or the numbers I have are based on this system. So normally when you are recording data using a GPS, it has already a system it is says in that. So when someone gives you information about X and Y, you have to ask them which kind of system communication they use to connect those data. Sometimes they also provide such information. When you connect the data, it will select this file you have used this coordinate system. So this is the allow because find the coordinate reference system for accurate mapping for latitude and longitude. This is the one which is commonly used. So most of these GPS we are talking about in normally use. This is like a world-known coordinate system. And if your X and Y are projected, we use what we call a projected coordinate system. So there are two types. I was about to even show you the two differences between a projected coordinate system. But for now, if you have the information used for collecting your data, either a geographic or a projected, you put such information and then combine it with the geometry you have created, and now create what we call the geodata frame. So the geodata frame is similar as a shapefile, but because we are using Python, they are meaning a geodata frame, and then we now start to read the data from from the shapefile of the data creator. But now, if you want to export your data into a shapefile, you will need now a function that will transform this data frame into a shapefile. That's just the idea. So all these, maybe if you want, I can give you access to these codes. Here they are. The last step is to plot it. Is to create the map from the data you have there. When you see plots, the geological frame is similar to plotting the shapefile or creating a map from the data in the geodata frame. We'll find time and try to do similar exercise of adding points from table and then try to map it on the wall. Any other question before we go back to the
Yes, sir. Why I'm going to use Python
the problem is because of the background. That is depend on the background. So if you are someone familiar with programming or you want to learn programming, you can keep using the Python. So for the desktop GIS software or applications, they are normally already defined or easy tools to use. So if you don't have any knowledge or you are not interested in this kind of mapping, you can still use this. But the desktop has also limitations. First, it's stored on our local machine. So when you are going to start processing this analysis, you can click and it takes you maybe 5 to 10 seconds. On the laptop, it might take 20 minutes. Because you are trying to compute something based on the computation of your laptop. That's the first limitation. And the size, maybe the storage, you might have huge data sets, maybe covering a large area. And your laptop or your machine is limited, you might face such challenges. Or you want to compute some analysis which needs a high computation. But only the tools. If you're interested in Python or other programming language, there's also tools available for you to use. Even the similar analysis you perform in ArcGIS, you can perform them using this platform, Python, or any other platform. And in addition to that one, it depends again on the community you are around in. Sometimes some communities advance more higher than others. So some people who are still using maybe desktop applications, there's no much development of applications available to them. But people who are actually using this Python, they are now taking over. So you have to find a way of learning what's coming up because it has the flexibility of even advancing whatever you're doing. For instance, if you have a similar task of doing the map, and then maybe we are given a week to finish that. Or maybe we are using Python, and it might take me 1 day. Because in your desktop machine, there's no way you can ask like such similar form. The one I have asked here. Converting my data from an Excel to a shapefile. You cannot find a similar tool in ArcGIS. But here, people have already advanced. They have created prompts where you can ask a question and then it gives you an idea of what you can do. So the desktop applications are really good and relevant but they are limited depending on how you want to scale.
Yeah, Python, I want to create
You know, when you install it on your again on your machine, it's possible that you can work it offline.
but we know the
Yes, the library. So the libraries we have started using these ones. These are the tools that you need. So maybe if I had, sometimes you can perform it using your own uh, laptop as long as you have the storage and the models or the libraries stored online. So for instance, this is a kind of similar script. Yes, you can ask the question.
Yeah, my question is that is it possible for someone to use Python without having knowledge of GIS?
Mhm.
Can you hear me?
Yes.
Hello, can you hear me?
Yes, we can hear you.
Yeah, I said that is it possible for someone to use Python only without prerequisite knowledge of GIS?
Yes, it is possible.
So is either someone use Python or someone use GIS. You can use both together.
You can also use both together. It's possible.
So okay. So if I can do all the things I do on GIS on Python, do I need to learn? Do I need any for GIS?
Yes, yes,
GIS.
yes. Right. So he's asking if someone needs knowledge about this, if they have already a background in Python. Is that correct?
Yeah.
Yes. It's possible, but we need sometimes there is you don't just need to add the data and perform the analysis. Sometimes the analysis you get, you need to understand the result. You can't just expect a script to give you everything. So it can give you a result, but you are the one to understand and interpret it. Yes. So sometimes maybe when you are performing any analysis of using this data, you can get the function to perform and do the result. But when the result you get is maybe an output from your analysis, you are the one to provide more detailed information. So you need such skills.
Hello,
Yes, yes.
can I ask you a question? Oh,
Yeah. Yes, yes.
all right. You know those extensions like SHP, it stands for shapefile. I don't know the extension for the others like SHX, CPJ, DBF, PRG, and so on and so on. You know, the two common formats for geodata are vector and raster. I don't know the others, and we have so many extensions I have never seen. I want to know those one. And the other is, can you also do the same map using like VS Code, PyCharm, or Jupyter Notebook and ArcGIS, like the one we do for Colab?
Yes, it is possible.
It's possible.
It is possible using either PyCharm or Visual Code. You can still do the same what you are doing here in Google Colab. The only necessary you need to understand how to install and import these libraries, because there is also a notebook for just the local desktop. And then the second question on the vector and raster. So normally these are the two types.
Yeah.
But depending on the someone who is under that the owner of the data. For instance, Google has its own naming. The S3, this ArcGIS has their own naming of vector and raster data. Some other industries might also have what you call your package. So depending on the someone behind, they name it as they want. But they are the two only features we have. Then the first one for this kind of files we see in shape files. So normally they are used to store different information. So for instance, if you want to keep the coordinate system, they are specifically stored maybe in this one called PRG. So everything you do on a shapefile, either editing, adding new information, or if you want to share it, sometimes they share it in another file, and they need to keep it this different like structure. So this is why shapefiles are normally complex. Sometimes if some file is missing, sometimes it doesn't open as a shapefile, and you need to check the data source and maybe the amount again the data.
Very good. Thank you so much. Can you also show us how to produce a map using ArcGIS Pro, like ArcMap? Because I have those one, I installed those one, the base code, PyCharm, the Jupyter Notebook, even ArcGIS Pro, I installed even the day before yesterday. I want to know about how to do this thing in ArcGIS.
ArcGIS, yes. We are trying to find a solution for that.
All right.
Very
Okay.
soon we will know how to make it perfect in this training.
All right. Okay. Thank you.
Let's This grammar. Let's learn about structural reference before we move on, before we go back to the analysis or the normal exercises. So we have two types of coordinate system. The coordinate system is simply a framework or a frame of reference. We basically when define the location of the space. So it's something to base on. It starts from when you are saying that this is my location or this is the location of this formation. So we have two types. The first one is a geographical system, which is a method of describing the position of the location on the Earth's surface. This equator. When you are above the equator, you can be between 0 degree and only 90 degrees. And then when you are also below, you cannot exceed 90 degrees south. And then the longitude, you cannot exceed 180 on the east side or 180 on the west side. So that's the idea. So when you are in the group, and then you are above, you have to know that you are between 0 and 90, and 0 again from the south, 0 and 90. And then again, it's measured in degrees because it's not a flat space like this one. It's something that is fair. That's why we use longitude and latitude to measure those information. So this is the first way of recording. The second way is using the projected coordinate system. Now they have tried to put this globe on the paper. So when you are trying to put it on the paper, that's why we need now to use what we call a projected, which is a system defining again the location on a flat or on a flat space. Again, we are talking about the Earth surface. And then this is one which is needed when we are starting to do any display or analysis of the data map. So one reason of using the projected is because even our laptops are already flat. You cannot just see the location without first making it flat figure. And then again, if you want to do some analysis like measurements, measuring where you are from another location, you have to first try to find a way of making your area flat so that you can measure any distance or any area distance you want to take. So these are the two types. So if you see someone giving you, or you are also familiar with someone giving you just information in degrees, you understand that it's going to be using a geographic coordinate system. And then when they give you information, sometimes it's in meters. Someone has recorded information and they just give you maybe this information, meters, maybe 740 meters. Again, the two values are projected because they are in meters. We are talking about a flat space where you can compute just distances. But because these are angular units, you just need to convert the information into angular units into latitude and longitude. So the two, let's see how now it's computed. The example of the location. This point first, if you consider this is an equator, it's located above the equator, and then if you consider this line as the Greenwich, it's located in the east. So this is the line of value you expect to get. So it is 60 degrees east and 55 degrees north from the equator. And then because it's an angle, it's not just a straight line, it's like an angle. So an angle has such value of 60 degrees and 55 degrees from the north. So this is the idea of how the degrees are computed. So to understand, we just need to draw like a globe and then try to split it into, here is an interval of 30 degrees, and then again 30 degrees, then we are looking at the globe and then try to compute the degrees. And this one and this one. So this degree is 55 north and this is 60 degrees from the east. So here they are explaining the difference between the latitude and the longitude. Latitude is the angle between two lines drawn to the center of the earth, one from a point on the equator and another from a specified point on the same region. Again, latitude is the angle between two lines drawn to the center. The center is here. So two lines drawn. One from the point of the equator. So the equator is this one. So this is the first line. And another from a specified point on the same in the region. So for instance, this is the first line from the equator, and do this one and this one, and then again we say from the same region. They should have touch the same region because the regions are the ones crossing from above to below. So two lines, this is the one which is touching the equator, which is this line, and then another one is touching the meridian, but the meridian where the first one has touched the equator. So this is the angle of the latitude. And then again, on the longitude, it's the angle between two lines, again, drawn to the center of the earth from the equator, one being at the prime meridian, and another at a specified meridian. So we have drawn two lines. One should be at the prime meridian. If this is the center, the prime meridian is the one crossing 0. This is the one with any other line touching any other meridian. So this is one meridian. On 5 there is also another one. On 6 there is another one. So if the first line touches the meridian and another meridian, which is this is the prime one or the Greenwich, and then any other one. So the angle is the angle between the two lines. So that's how we get the values longitude and latitude. The latitude and longitude are typically expressed as degrees, minutes, and seconds. You will see the common units, or they can be expressed as decimal degrees. So these are the only two ways of recording the longitude and the latitude, either using the DLS, the degrees, minutes, and seconds, or using decimal degrees. So an example of an example of the DMS degree, minutes, and seconds. It's 30 degrees. We say 20 minutes and maybe 5 seconds. And then converting this into a decimal degree, if this is 30 degrees east, when you are writing the decimal degree for this one, it's 30 dot it's not in the east, and it is in the west part, you add a negative here. That's the only difference. When it's on the eastern part, it's a positive value, and when it is on the western part, it's a negative value. Again, on the north and south, it's similar. On the north and east, they are always positive, and then on the south and the west, they are always negative. That's the formula. So sometimes someone gives you, like in Rwanda, we have a range between -1 and -2. Maybe that's 10. And then we are also again on the east of the Greenwich, which is almost 30 degrees. So you might get this value, and then you understand where it is from only observing. You understand that this is negative, it's below the equator, and 30 is east of the Greenwich. So you understand on which side are we. So if you have the globe and you're asked to show where this area is, you start from this one, -2. So from the equator, -2, it's below, and 30 degrees, because it's a positive, it's on the eastern part. So we might be located like here. So even just giving you the north and south or east and west, so they would change this one. They say it's 2 degrees, 2 degrees south, and 30 degrees east. So either way you can convert them into the two. That's how they are recorded. If you're importing data from with spatial information such as the Excel, the CSV, the angular unit of measure must be decimal digits. So this is a recommendation. When you are importing the data to actuaries, they require that they are not in degrees. They ask you to put them first into decimal digits. The ones with no difference must use the values structure. I think you understand why. It's because these are too complex to record. So it's better to just have a number, -1 and 2, or just -10 and 20. These are very simple to keep in a table compared to storing such good information. So that's why they give that exception. You can see them compared to yes. Even I think in Python, I think we might the reason they need to a simple degree or a simple unit of second. The data are shifted. Just a small portion. You might be here at Mahawanga, and then you just remove this 5 and then you put only 2, and you'll be shifted to another area. And when you are doing any analysis or just analyzing the data, it will be very difficult to compute any kind of analysis because the data are already not there. So it's better to first transform this data into decimal degrees, which are positive and negatives, and then start to do any kind of analysis you want. So these are explanation. In decimal degrees, values in south and western hemisphere are always negative when you are using decimal degrees. So this is an example. For example, this notation university is affected 32 degrees north and 106 degrees west. Instead of using this information, you can just skip the two values. 32 degrees because it's north, it's positive, and 106 degrees west because it's in the western part, we add the negative. And then it will be easy to understand. So let's try to do some exercise. So we'll go home when finishing this exercise. It's very simple. You understood now positive and negatives. Yes?
Yes.
So we have different cities here, and they are asking us to match them with those values. Yes. Where do we start? Let's start from Cape Town. Where is Cape Town located? Because first, don't look there. What is the advantage of Cape Town? Cape Town. Take your time, take your time. It's in the south. Where is the green bit? It's here. The green is here. The is here. So where is it located? So southeast. So from here, what is the difference? From 0. 19. From 0. From the building. Yes. Is it positive or negative? Positive or negative? Negative. It is 19, what? Or 17 or 18, whatever. Minus what? This is 30. It might be minus 30 what? So which of the because you see at the 5 values, which one is somehow up here? See here. This one? Yeah. This one? So this is the one. Yes. Negative. Starts for here, they start from what? From the equator. So this is the equator. We are almost at what? Just looking below. Almost 35, because this is the middle of this way. This is 10, 20, 30. This might be 35. The last 9. So it is nearest negative 34, which is this one. And then from the grid bridge, here, this is 10, 10, 20. And today it is showing what? 18. So it's almost 20. So go ahead and then what's your homework? You'll find other, I will just give it as an assignment for tomorrow. We'll start from here to keep the other values.
Hello. Just a quick communication. There are some people are seeing Python for their first time. That's the first. Yeah, we understand you. It's crazy in the starting, but we get you with artificial intelligence thinking. You don't need to cram the codes, the coding. You just need to understand the logic, how codes are structured. When you understand how codes are structured, artificial intelligence writes in the code, then you know how to follow the code. So, apart from that, we do more exercise. You get to understand from the mistakes. Then it's good to make a mistake. Yeah. In addition to that, you always have a recap session in the middle of the week. And that's where we're going to start with a deep understanding. Like we are using Python because we are how do I say it? We are using Python in Geospatial. When some of us don't know Python. On Thursday evening hours, we normally do the edition is okay. Between Thursday and Wednesday, 7 p.m. in the evening, we have a recap session. That recap session is supposed to take us. It's a 2-hour session online, and it's on. No one requires you to attend, but if you feel interested, it's that moment where you really ask each and every question that you have. It is that moment where you start, like, things start opening up. You start connecting dots. Because the more you get, it's the more you get. When you keep them, it's the presidents of coding and these technology-related things, you forget it. Yeah. So practice is the only approach we use in learning. So we're going to have that session, but even during this in class session, we realize that we are doing more practice. We are focusing on the practical part of it. So you understand how we keep practicing. This has all to do with maps. That's our focus in this particular training. It's not mapping differently, using different kinds of. Yeah, if you have any challenge, any question, remember we have Benjamin, we have Brancha, we have Patrice, and our trainer. They are all in that WhatsApp group. So in any case, when you have any question, please don't fail to ask. Yeah, apart from that, I would say It's how you evening and tomorrow it's the same time. You can't take it. Even though it's calculated, the trial is here. The only time we have to compromise is in Uganda because it's trial, but calculated, we know, by the way. Breaks.